How to design software architecture, top tips and best practices. You wouldn't want to jump into a project without a solid plan, and software architecture design is no different. By making this process more effective, you can account for all of your requirements properly and give stakeholders the opportunity to provide their input. Using technical visuals and a careful planning process, you can outline your software architecture and design before you get started on a prototype. What is software architecture design? Software architecture design uses programming knowledge to plan the high-level design of software so that detail can be added later, allowing software teams to sketch out the big picture and begin preparing a prototype. By following software architecture design tips and best practices, software developers can think through their software's characteristics and determine how to design software architecture. How to design software architecture in 5 steps. 1. Have a clear understanding of your requirements. Every design you embark on will have both functional and non-functional requirements. These requirements guide your software architecture along and allow you to finish the project with an end product that your stakeholders are satisfied with. Without a clear understanding of these requirements from the beginning, your team runs the risk of getting lost, emphasizing the wrong requirements at the expense of others, or using an inefficient amount of internal resources. Gain a better understanding through visuals. Follow these steps to map out your requirements in an intelligent diagramming platform like Lucidchart. Start with a high-level view. Sketch out your requirements at a helicopter view first. Mind mapping is an effective way to do this. Map your functional requirements. You can use verbs to help you cluster nouns together. For example, verbs such as view and edit can link account or profile to each other in a mind map of functional areas. Consider non-functional requirements. While you're working on your mind map, you can jot down your non-functional requirements for later. A requirement like performance is key but is probably too abstract to place on the mind map. Your requirements should be used to shape your scope of work and plan out your project. 2. Start thinking about each component. Let's face it, with the powerful influence your functional requirements have on your project, your design and technology options may be already decided once you've mapped out your requirements. Without getting too far ahead of yourself thinking about implementation, you'll need to find out which requirements pose significant challenges to your design or your project plan. Some requirements may actually be impossible under certain assumptions or choices. Start with a perfect world. What would your design look like if you could create it perfectly? Consider and document the implications of your requirements. Start a working draft with your team and develop it gradually. First, you want to look at what your requirements imply for your design. For instance, where individual items from your stakeholder wish list may contradict each other or be in conflict with other functional and non-functional requirements. Wait and design the final architecture later. In all likelihood, your architecture planning will change throughout this process, so don't expect the first draft to resemble the final result. 3. Divide your architecture into slices. Your architecture design, naturally, moves into a planning phase as you decide how you'll deliver on your design. Dividing your architecture into slices can help you craft this plan in a way that delivers value to users and appropriately plans your use of development resources. It's helpful to think about slicing a cake. Most people slice a cake vertically, through each layer. Let's say a full slice has frosting, filling, and 2 or 3 layers of sponge cake inside. That vertical slice has a little of everything. Cakes can also be sliced horizontally, separating individual layers. Similarly, if each slice is a story used to plan your software architecture, then there are layers. Slicing the cake vertically creates stories centered around individual features, while slicing horizontally reveals individual components. You need both horizontal and vertical thinking for your project. Agile focuses on vertical slices, allowing your team to quickly deliver value. This approach provides customers with product progress quickly and the development team with feedback on each layer behind a feature. One vertical slice of your software architecture for an e-commerce website might be the checkout process. In your checkout vertical cake slice, you can see the data layer storing the checkout information, the middle layer API, and the top layer user interface that shoppers see. With vertical slices, you can decide which features to deliver and choose iterative pieces. By diagramming the layers involved in your software architecture project, you can visualize the entire piece and how each layer influences other layers. As you plan, take individual agile cake slices and diagram how they connect. 4. Prototype. Always create a prototype. Prototypes allow you to fail fast and early, providing quick feedback and allowing you to discover your proof of concept. This is an important part of validating your work and checking your assumptions to make sure they're valid and thorough. As you create your prototype, remember that the first few iterations will never be perfect and no final iteration will be completely perfect, either. One of the advantages of prototyping is that it doesn't set itself up as a finished product, and most people instinctively go into a prototype process expecting at least some rough edges. Take advantage of the prototype phase. This is no substitute for testing, but it is a crucial part of the testing you'll need to do. Keep a careful revision history. Of course, if you don't document what you learn from prototyping, you run the risk of repeating your mistakes. Write everything down, thoroughly document your design decisions and the changes you make along the way. Have a single source of truth. You don't want multiple changes and different versions to sidetrack your progress, so set up robust version control focused on a single source for your documentation. Diagram your prototypes. You can use diagrams to help you manage prototype changes and visualize the differences between each version. 5. Identify and quantify non-functional requirements. In addition to the functional requirements, you'll have non-functional requirements to take into consideration. These requirements are as essential to design as your functional requirements are because they define the system's characteristics. Non-functional requirements are often high-level quality requirements for the entire project, but not always. Your system may have non-functional requirements that are specific to just part of your software architecture. As such, you have to be prepared to loop in stakeholders for local non-functional requirements. For instance, a particular vertical slice of the project may interest the customer service team in particular, and that team may have their own expectations about those non-functional requirements. It's not enough to say you want performance, portability, or scalability, though. Non-functional requirements must also be quantified. No project can have absolutely perfect performance. Performance must be specified and limited in order to meet other requirements. Since your non-functional requirements play a role in shaping your design, you can't avoid defining them. Here are some other requirements you may want to consider. Performance: how well your entire system performs as well as individual slices or layers. Scalability: current and future potential to scale your system along with your needs. Portability: your data portability as well as the potential portability of components of your system, if applicable or necessary. Extensibility: accounting for your system's and company's future growth, how well your system can adapt and the effort involved with adaptation. Compliance: another essential factor and one with a sizable impact on your overall project design. Diagramming your non-functional requirements can help your team see how you're quantifying them while also placing specific requirements in relevant contexts. Although you don't have to worry about optimizing everything just yet, you do also need to consider what effort and resources might be necessary to optimize these non-functional requirements later. Best practices for software architecture design. As you undertake your design project, these best practices will help you stay grounded in good design principles. Visualize your design. Using visuals throughout your design concept work as well as your implementation allows your team to see the high-level perspective behind your design. Diagrams are a great way to visualize processes and different aspects of your design choices. Don't choose patterns. Keep your design process focused on the bigger picture without resorting to patterns as a starting point. Instead of using patterns, stay very high level with a view of overall components to reduce the risk of over-engineering your systems. Remember that the first design is only the first iteration. With your first design, you're getting a better idea of the technical challenges and obstacles you'll face with your architecture development. Don't expect the first design to be anything more than a prototype. Don't worry, your architecture design will grow and develop, allowing you to figure out more of the details over time. Be cautious of scope creep. Even if it seems tempting to allow your scope to grow, scope creep comes at the expense of your other requirements and can eat up necessary resources. To stop scope creep, establish a working draft project plan that accounts for your requirements and have a conversation with stakeholders about limits to non-functional requirements. You don't want any unmet expectations to adversely affect your project. Keep boundaries and interfaces in mind. As you plan your design, think about interfaces between components and note the boundaries of your system. Start assigning responsibilities so when you work on your prototypes and next iterations, you have this information available for easy reference. Improve your software architecture design now. Software architecture design is more effective when there is a plan, stakeholder input, and the right approach to outlining requirements for the project. Don't skimp on this early planning, and your efforts can be rewarded with a smoother project experience.